Hello everyone. Today let's solve the problem 377, problem number 377, combination sum 4. We have already solved the combination sum 1, 2, 3, right? So we'll be having the idea, man. So let's see what the question states here. So given an array distinct integers, right? So we have been given the array nums, which consists of the distinct integers. See, all the numbers are distinct here, meaning all the numbers are different, right? So 1 is different from 2, 2 is different from 3, right? All the numbers are distinct or the different here, given the array of the distinct integers nums and target integer target. So see here, this one target integer target. So this is nothing but the target consists of the integer as well. So we have to return the number of possible combinations that adds up to the target. So by making use of the this one elements present in the nums array, so we need to return the number of positive combinations that add up to the target. Only the positive combinations they have strictly mentioned here, right? So again, the test cases are generated so that the answer can fit into 32-bit integer. Yeah, this one you can just ignore for now. Yeah, let's move on with the main this one part. See here, we have been given 1, 2, 3. The elements we have 1, 2, 3 within the nums array. So we have to return the number of this one. What do we call? Mm, Number of different ordered sequences, right, of the elements from nums, that sum to target basically in simple terms, right? So here 1, 2, 3 we have target, we have been given 4. So the possible combination ways are, so yeah, we can just go with 4 ones here, 1, 1, 1, 1. Yeah, this is also one combination. Yeah, so let me delete this one, let me consider this one directly. 1, 1, 1, 1. This is also, this sums to the target, right? So we can just make use of the same number n number of times, it doesn't matter. Next we can go with 1 twice and 2 once, so that also leads to 4. 1 to 1 also leads to 4. Here you can just look into it. 1, 2, 3, this one 3 and 4. 1 and 3 sums up to 4. 2, 1, 1 sums up to 4. 2, 2 sums up to 4. 3 and 1, this also sum up to 4, or sums up to 4. This is fine. Now these are the combinations. So this one total number of this one combinations we have here is 1, 2, 3, 4, 5, 6, 7. So total 7. 7 is the output that we need to return here, right? 7 is the output that we need to return. So let me delete this one. Let's move on with the second example here, right? So here we have 9 and the target we have been given 3. So here none of them sums up to the 3. The number itself we have been given 9. So how many times we have 9? 3 is greater than 3 is smaller than 9, right? So we cannot make use of it at all. So right, to sum up to the target basically here, we cannot make use of the elements in the nums array that can sum up to the target. So in that case, we have to output 0. This is fine, I believe. Yeah, they have given us wonderful examples just for the sake of understanding. Yeah. Now we have the good understanding of the question along with the example or the input output. Now let's do one thing. Before hopping into the approach part, let me tell you one thing. So we will be making use of the DP to solve this problem, or 1D DP. So we will be going with a 1D DP basically, right? So just remember this. Let's move on with the approach part, man. So the first thing what we will be doing here, so we will be making use of the 1D DP, nothing but the DP of S here. So we will be going with DP of S. This is fine. DP of S, which is equivalent to the number of ordered sequence that sum up to S, right? So that sum up to S basically, and we will initialize DP of 0 initially to this one. We'll initialize DP of 0 to 1, right? So there is only one way to make this one sum 0, right? So we don't have to take anything. In the second example, we did the same thing, right? So that by the integer 9, we were not able to sum that one, sum up to this one target 3. The second example, you can just look into it, right? In that case, we have to go with a 0, right? So that's what. Initially, we'll initialize DP of 0 to 1 because there is only one way to make the sum 0. Nothing but take nothing in that case. So for every sum S from 1, so this is second step. For every sum S from 1 to target, from 1 to target, right? So we will try every number in nums. We will try every num in nums. We will be trying every num in nums, right? So this is fine. If num is less than or equal to S, suppose if number is less than or equal to S, then the sequences that end with a num equal dp of S minus M. So we can just go with dp of s minus 1. And this one has to be less than actually. The numbers has to be less than or equal to this one target. Else we can directly return false here, right? So this one has to be num. dp of s minus num. So this counts the sequences, nothing but here order matters, right? So because we build sums increasingly by the total, and we also allow every num to be appended, right? The same thing here. Let's implement for the this one. Let's implement the same thing on the example one. You'll understand this one crystal clearly now. Yeah. Let's take the same first example. This one they have given in the question, basically this one. Yeah. Now first what we will do, we will be initializing dp of 0 equals 1. Right. So accordingly with the approach, this is fine. Now when s equals 1, so we are going with 1, 2, 3. Initially when s equals 1, what we will do, we'll be going with a dp of 1 plus dp of 0. dp of 1 is dp of 1 here is 0 and dp of 0 is 1. So basically we'll be going with dp of 1 equals dp of 1 plus dp of 0, right? dp of 1 is nothing but 0 and dp of 0 is 1. It will be 0 plus 1. This will lead to 1 actually, right? So dp of 1 here is equivalent to the this one, what we call 1, right? So dp of 0 is 1. Now when s equals to 2, right? So we will try 1 first. So dp of 2 equals dp of 2 plus dp of 1. So uh, this one, what do we call? dp of 1 is 1. We know that. And dp of 2 equals dp of 0 plus dp of 2 plus dp of 0. That also we'll go with. Then also it will be basically 1, right? So this will be dp of 2 is 0 and 0 1 we have, right? So basically we'll be going with this will also give 1 actually. dp of 2 equals dp of 2 plus dp of 1. Then we can just try the second one, like dp of 2 equals dp of 2 plus dp of 0, which will lead to 1 as well. So it will be 1 plus 1. dp of 2 will lead to 2. dp of 2 this one lead to 2, right? So this is fine, I believe. Now we have dp of 1 basically. So this one has to be dp of 1, not the dp of 0. dp of 1 is 1, dp of 2 is 2. And let's try the 3. Now we have to go with dp of 3 equals dp of 3 plus dp of 2. And we can go with the second combination, dp of 3 equals dp of 3 plus dp of 1. And the third one is dp of 3 equals dp of 3 plus dp of 0. So first one will yield to 2, second one will yield to 1, and the third one will yield to 4. So we can just go with a 2 plus 1 plus 4 actually. 2 plus 2 plus 1 plus 1 actually, right? So 2 plus 1 plus 1 will lead us to the 4. So this one dp of 3, basically dp of 3 is nothing but the 4, the value 4 we got here. Finally we will try for the 4 when s equals 4 actually, right? So we'll try one again, same thing. dp of 4 equals dp of 4 plus dp of 3. Same thing goes with the dp of this one. We'll be summing up with dp of 2, dp of 1, and dp of 4. Sorry, we'll be summing up with dp of 3 as well as the 2 as well as 1. Right. So this will be actually 4 plus 2 plus 1. Nothing but this will be 7. So this one will be for the dp of 4 actually. This one will be for dp of 4. The value we have here is 7, right? So now this one, what should I say? Result is nothing but the dp of target. We have completed this one, right? So now result is nothing but the dp of target. dp of target here is dp of 4. dp of 4 we have got here is 7. So the output that we got here is 7, which is equivalent to the output that they have shown for the example 1 within the question. Now as we are completely familiar with the approach, let's do one thing. Let's quickly discuss the complexities part. So that is how we got the 7. So this is how we will be making use of the DP as well. So possible combinations we have directly known here. So that is how we'll be making use of the DP approach I have shown you, right? So this is fine. So what will be the time complexity here? The time complexity would lead to this one because of target into n, because of target into n. So why the time complexity here is because of target into n. So n is nothing but the nums of the length. We know this one, right? For each sum 1 to target, we iterate all the numbers. So overall time complexity would lead to because of target into n. So what will be the space complexity here? The space complexity would lead to because of target. So why it is because of target actually? this is big of target for the 1D DP array of length target plus 1. 1D DP array of the length target plus 1. So the space complexity would lead to big of target actually. The time complexity and the space complexity for the code that we'll be writing in the future would be big of target into n and big of target respectively. Now, as we are completely familiar with the approach and the complexities, we are good to write the code. Let's start writing the code. Initially, we'll be going with a DPR as I've said, right? So DP of S will hold the number of ordered sequences that sum up to S. So let's allocate the 1D DP array of size target plus 1 initially, right? So I'll just go with int here, DP equals new int of size target plus 1. Yeah. Next step would be base case DP of 0 equals 1. We know this one from the approach. Now this is fine, man. Let's move on with the iteration part. So we have to compute DP of 1, DP of 2 up to DP of target we have to compute, right? So target in the sense this one 4. So we went from S to S equals 1 to S equals 4 in the approach, right? By considering the first example. So we have to go until DP of target, right? So let's move on with the iteration part. We are done with the initialization part. Let me go with the iteration part. So this one will be int S equals 1, S less than or equal to target. So let me increment the S. So within the for loop, let me initialize base to 0 as well. So let me go with one more for loop here. Int I equals 0, I less than length of the nums I plus plus. So this is fine. Yeah. Now we are just trying the each number in the nums, right? So within the for loop, let's go with the current number to consider, right? So I'll just go with nums. We have to go with the current nums to consider itself, right? So this one will be nums of I. This is fair. Next, if it can contribute to the current sum s, then we have to what we have to do then? Then we have to go with the sequences that end with a num or dp of s minus num, right? I can just write it in this way. Let me go with a simple if condition. Num less than or equal to s here. So I'll just go with base equals base plus dp of s minus num, right? So this is fine, I believe. Let me come out of this one entirely. Now, let's store the computed number of base or the calculated number of base for the sum s. So I can just write it in this way. dp of s, let me assign this one to the base. Finally, we are left with only one step, that is nothing but the answer. So we have to go with the number of ordered sequences for the target. In simple terms, let's return here dp of target, right? So this is fine. So let me format the code once and let me hit the run button. I hope this works. Right, let's see. Yeah, the sample test cases are getting passed. So let me hit the submit button. So you can clearly see here, all the test cases are getting passed. Means the code works absolutely correct here, right? So the code works absolutely correct for all the test cases. I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.